Today, it's one of those underappreciated Cybernet 134 radios, the Fidelity 2000. I don't know what people get them muddled up with, but they're excellent radios. And this is coming from an end user. We don't do end users, as you know, but during this lockdown period we have done one or two just to help out. What I don't want to do is to take business away from shops, but when shops aren't open, you know what I mean. So, this is the factory original box, and I don't like to damage it. So we'll open it with a knife. It's Mr. Chippy's knife. We had new lights in the back workshop that Mr. Chippy uses. We've got 2 double 5-foot LED instead of fluorescence. That's from a single double 5-foot fluorescent to 2 double LED of similar power. Oh, this goes to Cheshire, does it? He found a loose wire in the microphone plug. I'm glad about that because we don't repair microphones. So, one of the tubes was faulty. So, the two which weren't over, the two lights which aren't over his bench, only one of the tubes is working. The two lights which are over the supplementary benches I've been using recently are working. So it goes in there and you go, oh, blow me. I noticed the ones over your bench are working. Well, it was just the luck of the draw. As I put the tubes in, one didn't work. And we bought these lights 2 years ago. There's not like no redress. I can't moan and say one of your tubes is faulty. I'll get Mr. Chippy to strip it down. He might find there's a crack in a printed circuit with these LED things. But nevertheless, I ordered replacements. But yeah, it was typical that it just happened that it was over his bench where one of them isn't working. So I'm glad this has got a warranty. I'll tell you what, this would have been a good candidate for working, wouldn't it? It would be a really good candidate to have done a kind of on the air test. Well, I'm glad about that. It's got 4mm plugs on it, which makes it doddle to plug into our power supply. So what's nice is it is the original microphone, and it's got all the screws in there. Yeah, I'm all for, you know, when you're selling things like this, to put some stickers on, because there are some unscrupulous people who will nick transistors out of things, aren't there? You know, and worse. So we'll just plug this into our power supply. And I'm going to do a test before we break any of these warranty seals. I think that's a very prudent thing to do. Okay, so it's come on and it's on 19. RF gain at full, mic gain needs to be at full, squelch to minimum, volumes there. So I'll just plug I'll plug the SINAD meter into the appropriate socket, make sure the radio's on high power, gets in normal mode. Right, let's. I'll put picture in picture, and then you can see the power. I'm going to make a note of these on the back of his letter. I won't show you his letter because it's got his address on it. Okay, so it's doing 4.3 watts. So that'll have to come down. Now that's on channel 20. On channel 1, it's doing, because this has to be balanced, it's 4.5 watts, and on channel 40 it's 4 watts. We put the spectrum analyzer on, and whilst that boots up, we'll look at deviation. Well, with the tone it's 1.2, which would be low. Low, and it's 1.5, which is too low. So that's let's look at what the meter says. It says it's gone boing right across to 5 watts. Click back to channel 20 for fairness. And we'll dial 2779125 into the signal generator. Now what we're listening to there is 0.3 of a microvolt, and we'll move this test instrument up to the SINAD meter, and all I'm going to do is we'll do the 12, which is the industry standard. Now I think that I should be able to hear this set better than that. Let's turn the signal generator off so you can hear it. Off, on. If I didn't know, I would say the detector's out, because I think the signal to noise ratio is poor. So we'll put S9 on it, and we've got S9, and we'll now look at that SINAD meter and see what we've got. I want you to all know that the RF gain is at full. The radio is doing 2.7, 2.85. 12 dB SINAD equals 2.85 microvolts, which is rubbish. And I'm not going to look. I am going to move this down to that attenuator so you can all see. This really would have been a really good one to do as a scratchy corner before and after, but it would delay the customer getting the radio back for 36 hours. They have to be done at 8 o'clock in the evening because of Mr. Chippy's working pattern. So this knob is on 3. So this knob, this is the fine-tune one. I just hope we can see that. It starts, the attenuator starts with 3 point something. So if I turn that to the maximum, we've got about 14 decibels of SINAD. So as I drop this down, you can hear it getting scratchier. That'd be 0.1 of a... Am I on the right scale? Yeah, that would be 0.1 of a microvolt, 0.15, 0.2, and then we go up to actually 3 microvolts. So it's pretty crummy. I bet the person who sold them this, I bet they'd love to have this beautifully working. Right, we'll take it apart, break all those lovely seals, and see if I can find a screwdriver that has gone for a little walk to the floor. So I've just wasted 5 minutes in proving this radio doesn't work properly, and that's, the customer isn't paying for that, but it's just so you all know, when I break these lovely seals, hopefully it's going to be a much better radio. It's a bit of a push-in screw. And as ever, we're going to start on transmit. I will just check the VCO voltage just in case it's being messed with. And it's a pluggable speaker, which is always nice. The good news is it doesn't look like it's been messed with. I'll tell you what else we'll look at together, and we'll see how on frequency it is. Oops, I've gone past it. That's showing my signal generator at the moment. So we'll go over to transmit. I'll press transmit. Should be 2779125. It's 2779112. That's absolutely fine. It's, you know, they drift down with age, and we'll bring that back up right now. So we'll just do that, and it is the red trimmer next to the crystal, just there. One, two, one. I like to have them just slightly above, so there's a little bit of headroom for them to drop. Not that much headroom. Let's try the ceramic tool. I think that's ideal. So I'll just check the VCO. I'm going to select channel 1. Just turn the volume down for now. I think these are a floating chassis, so we'll just connect the negative prod to one of the cans. Just put the other glasses on. I basically want this to be on 4 volts on transmit and receive. That's in lock. I don't need to go any further with that. It's not scary. I'm not going to go through the procedure. We've done it millions of times. And but that's fine. That's not silly. So Cybernet 134. Without digging out the information, which I'm going to have to because I've got a memory like a sieve. Okay, so we're looking at transformer watt. Two, 3, 4, 8 and 9. 2, 3, 4, 8 and 9. And all those are set to maximum at this point. Two. Make sure we're on. I'm glad I checked that. I was on channel 40 from checking the VCO. So we'll just move this across to the. Whoops, wrong one. So at the moment we're on channel 20, and it's cold at the moment. It's about 4.5 watts. So that's maximum. That's fine. That's maximum. That's fine. One at the back is number 4. That's fine. Then, with the green tool, that's hiding, we're going to maximize. What are these? L4, L6, L9 by the looks of it. Could be 8. That's just going round and round. That doesn't help us. I think it's a tool that's got on the worn side of things. I think we're going to have to get another one out. Luckily there happens to be one here. Right, maximum. 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 So absolute full pelt, it's doing about 4.8 watts. Now we have to balance that, otherwise, like it's come, we've got 4 watts on one channel, you've got 4 point something on another channel. It needs to be as balanced as possible. So what they want you to do is to rotate the coil of L4, which is our first one, for 4.4 watts. So we'll rotate that clockwise. This is an important thing. L4 is rotated clockwise to 4.4 watts. That is 4.4 watts. Then L9 is counterclockwise to obtain, they say 3.8 watts, but we're going to do 4 because we're not having to ship it to another country and have it inspected. So counterclockwise for 4. Then we check on channel 1 and 40 that it's kind of within 0.2. So channel 40, it's 4.0 something. Channel 1, it's 4.0 something. Channel 20, it's 4. It's balanced, it's spot on. So now we'll look at that with the spectrum analyzer. I didn't look at it before because it was going to be a waste of time and it was probably clean anyway. So we'll just loosely couple that as we do. That just means in the vicinity. Just put that in the vicinity there. So I'll just move this camera onto the spectrum analyzer. So now press auto when I can find it. There we go. Key up. So there we have the transmit, and let's just look up there and down there, and that looks absolutely fine. So I've every faith. Just look what it's like at 54 megs. So frequency 54 megs. That's our harmonics. I can't see anything there. It's as clean as a whistle. We'll turn the spectrum analyzer off. So that's spot on. Let's look at that deviation. So we need that one to centre. There's R71 to centre, if I remember rightly. Just retune the... And then we need to adjust for 2.2. Switch that off. Wallow. Wallow. Could do with coming up a fraction more. Wallow. Now I managed to get it to peak at 2.5. Do you know what? I just didn't. I just realised I hadn't got the camera on the right bit. There's 2. We were at 1.5, which is too quiet. 2, which is about where a lot of new sets are. 2, 2.2, 2.5. Voila! I can just make it on absolute peak. Do the 2.5, which is where we want it. We want it to be averaging around 2 to 2.2, which is what it's doing now. So that's sorted out his mic, his transmitted audio problem. It's brought his power down slightly, but it's all, now all balanced, and it's as clean as a whistle. As I say, I could have looked at it to see how clean it was before, but it was really futile. So let's look at the RF meter. It was banging across, wasn't it? As it was. So let's see where that is. It's still banging across, saying a ludicrous 5. So it's that adjustment there. Do you know, it's not easy to see a red needle. There we go. And now we'll check low power. That's the switch at the back. Now I want it to do 400 milliwatts. These are often dirty, and I'll clean it before starting. So low power, as it's been supplied, is doing, well, that's 3 watts, so it's doing 1.2 watts, which is silly because the whole idea is it's 400 milliwatts. There we are. There's the 5 of 0.5, and there's the 400 milliwatts. So high power, as it's got cold, it's now doing something like 4.2, but it'll soon drop down. Good, that's his transmit sorted. What I was more concerned about was the lousy receive. So we'll go on to the oscilloscope. We've got a forthcoming look at a Heathkit grid dip oscillator. For those of are more into amateur radio, especially a more traditional sorting things out yourself amateur radio, we use those to look at resonant frequencies and the quality of tuned circuits. So that's been sent to me courtesy of Eddie, who lives not a million miles from Corby. Right, we want an S9 signal, that's 100 microvolts, and we want this to be plugged into, it is, there we go, well that's non-sinusoidal, in other words it's lopsided. So the detector coil on these radios is the one in the corner there. What's that diode for? How does that do? We'll switch it to PA and what happens? Well, we'll check PA works before. Don't know what that's about. I will just check the underside of the board to see if there's anything sneaky naughty underneath. Anyway, back to the reality. So, the detector coil there, we need to, with an S9 signal, have that for maximum. And it was at maximum. So what we've got a problem now is one of the IFs is out. Is it that one? So are they factory wires? I don't know. A bit stretched, the mic gain ones. And we'll look at that one as well. It's that one. Yeah, the IF was out. Okay. So now we'll do the front end. The IF stands for intermediate frequency. And we've got the 455 kilohertz one, which the detector's bolted to. And you've got the 10.695 one, which the other filter deals with. It's double conversion for better selectivity. Right, so we'll start with the front end. We want about 4 decibels on there. So I'm going to have to up that. So we're now looking at 0.7 of a microvolt. Can't say there's any improvement there. Can't say there's much of an improvement there. So I'll go down those again. We'll just drop that down a fraction because there was a slight improvement. And then these IF ones, I'll just touch them up again. Put a bit more signal on, probably about 12. And I'm now looking between, and I'll just zoom out. I'm looking between the oscilloscope and the SINAD meter. I'm looking at both simultaneously for the best quality as well as SINAD. So that's, I'm happy with being at peak. So now that's 0.3 of a microvolt. Okay, so I'll go back into record now. Right, having gone through this time and time again, we've got it. We're listening to 0.06 of a microvolt, and we now have 12 decibels SINAD, and that is 0.15 of a microvolt. So we'll write those down on the back of his letter. So before, so we had done 3.95 watt, 4 watt, 3.95 watt, deviation equals 2.2 kilohertz, 12 dB SINAD now equals 0.165. Somebody said to me, does volume affect it? So there we are with the volume, as you can hear, at absolute minimum. And if we turn the volume up, comfortable. Not really, unless we start getting distortion from the amplifier and introducing noise, because the SINAD meter has automatic gain control. Right, so just for the record, for 10 dB SINAD, so 10 dB is 0.13 microvolts, and 20 dB SINAD, if we can do it, is 20 dB SINAD is 1.1 microvolts, which is down to noise in transistors, as it still is 38 years later. So let's look at where that S meter is. Did we cover that? I can't remember. It was about right, and it's actually spot on. So the S meter's spot on. Where is the S meter if we wanted to adjust it? It's that one down there. Now we're going to check the squelch. So I'm going to stay at, I'll tell you what, we'll put the radio to 0.3 of a microvolt. We'll turn the squelch to full. We'll now advance the signal generator, and I'll move this down to the attenuated control so you can see what I'm doing. So 0.3 of a microvolt, that's at its end stop, that's at 0.3. So now I'm going to advance the squelch to full, which I've done, and there is 100 microvolts. I want the squelch to come in at that point. I want it to open up. So 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. It's spot on, absolutely spot on. And if we needed to adjust that, it's the preset, which is just down there, just under that wiring. And on the minimum setting, switch the signal generator off, advance the squelch to threshold, and switch the signal generator on. It's coming straight away. Let's see exactly where it is. It's coming in at 0.22 of a microvolt, and it's leaving us at 0.18 of a microvolt. 2218. There we go. That's fine. So that's some things which were spot on. Just check that transmit. It's still doing 4 watts. Good. So jobs are good, and as they say. So basically the IF was a bit screwed up on it. The point is the radio would have worked, but it did a bit deaf. And it was transmit, you know, I don't like this, well, I don't want it to be overpower anyway, but I don't like the idea of it being, you know, like 3.8 watts on one channel and 4.8 watts on another. And you don't know what rubbish is coming out. So, that feels a bit funny. Am I trapping something? I put it in the wrong way around, that's why. I'm just going to look underneath. So I'll tell you what we'll do. Because there was kind of an extra diode and an extra something. I mean, it could be because somebody's had one of those K40 speech processor mics and they've done a little modification so that it gets its power. You know, that was something which was going on at the time. You look, well, I forgot to take the lid off again. But this would have been a good candidate for a scratchy corner before and after test, and I say we will do that sometime, but with one of our own sets, I think, because I don't want to delay customers' sets. I can't see anything wrong under there. Fine. Still receiving, still transmitting. Wallow. We'll just listen on our little monitor receiver. Testing 1 2 3 4 5 5 4 3 2 1. That sounds great. So we'll do an on the air test with it later on, but I will just plug an aerial in for a laugh. I don't care an iota about the fraying of that wire at the end, so don't bother saying to me you've got a frayed wire at the end. I don't care a toss. One 9 a Roger. Anybody out there? 19 a Roger. They can't hear me over their burners. So I'll just check it on PA. I will do because of what I spotted. We use mic gain on these to do the volume. Testing 1 2 3 4 5. Yeah, that's working fine as well. So there we are. Nice radio. Yes, it was working as he got it. It needed the IF unscrewing, and it's all beautifully spot on. I'm sure the customer is going to really enjoy having this, and it's something to hang on to because the new radios do not work as well as this, and that receiver is now absolutely exceptional. To brought that 12 decibel from 2.85 microvolts to 0.165, you know, even Radio Crunch will be impressed. Thank you for watching.